A very good morning, good afternoon,
Good afternoon, sir.
good afternoon. Okay, so we will start. Should we wait for 2 minutes? We'll wait for 2 minutes and then we'll start. Some of the students are still joining. Just wait for 2 minutes and then we'll start. Okay. Okay. Is my screen visible?
Yes, sir.
Okay. Okay. So in last two lectures, what is the takeaway? The takeaway points are data preparation. That means the data collection, data processing, input, output, and data storing, and then database management system, what we have seen. Beyond that, now we are going to move towards the the part which we took was about the features also. So after the data collection and processing, then the most important thing was feature types, then we saw feature construction, then we saw feature transformation. So there were two categories, that is feature aggregation and feature transformation. So feature transformation, we were applying the algorithm only on one or two columns, but in case of feature transformation, we apply it on the full table, whole table, and accordingly the features are can be transformed. So feature transformation actually takes to the modification of the data, even if the reduction of the data. So but even if the if even if the data looks differently as compared to the original one, but that will help you to segregate the information from the data. So that was the last time what we saw was the database management system, data processing, feature types, then feature construction, and then comes feature transformation. So all these things we saw in the last lecture. Now we'll move towards the next part. This is the seventh lecture. We are going on machine learning algorithm, introduction to machine learning algorithms. So after the feature extraction, just a moment, I got a so now we are going to move towards the feature selection. So feature types, feature construction, feature transformation, and now the feature selection. So this is also one of the most important part, how you're going to select the features in machine learning. Which features do you feel as an important and which are not important? That selection is very, very important in case of feature selection. So it is the method of reducing the data dimension, first most important thing. While doing the predictive analysis, obviously you're going to predict the output. One major reason is that machine learning follow the rule of garbage in, garbage out, and that is why one needs to be very concerned about the data that is fed being to the model. यानी कि फिर एक बार डेटा ड्रिवन मशीन लर्निंग के बारे में हमेशा ये बोलता आया हूं कि इट इज अ डेटा ड्रिवन. So data driven means the data which you're going to fed to the model has to be very, very important. So you cannot put a garbage there, you cannot put an unnecessary data to feeding to the model. So you have to take care that very quality kind of data has to be fed to the model, and that's why feature selection here becomes very much important. We will discuss various kinds of feature selection techniques in machine learning and why they play an important role in machine learning tasks. The feature selection techniques simplify the machine learning models in order to make it easier to interpret by the researchers. It mainly eliminates the effects of curse of dimensionality. Obviously, when we are feeding the data to the model, dimension बहुत important हो जाता है डेटा का. अगर आपका डायमेंशन गलत हो जाए, डायमेंशनैलिटी मीन्स द डैश बाय डैश काइंड लाइक m by n matrix, n by n matrix, and your two dimension, one dimension, three dimension. सो डायमेंशनली रिडक्शन के लिए मोस्टली कौन सा टेक्निक यूज करते हैं? देखो, प्रिंसिपल कंपोनेंट एनालिसिस, पीसीए। ये एक टेक्निक है जो डायमेंशनल रिडक्शन करने के लिए काफी काम में आता है। क्योंकि क्या होता है, सपोज अगर मैं ऐसा बोलूं कि मेरा टेक्स्ट डेटा जो है वो 1 डायमेंशन है और मेरी जो इमेज डेटा है वो 2 डायमेंशन है। अगर मेरा सारा कैलकुलेशन 1 डायमेंशन के हिसाब से है और मैं तो इमेज फीड कर रहा हूं जो 2 डायमेंशन है, तो आई नीड टू कन्वर्ट इट इनटू 1 डायमेंशन इन ऑर्डर टू इंटरप्रेट। henceforth it becomes very much important to have the proper dimensionality. That is very important. So feature selection technique actually helps to make it easier to interpret by the researchers. Besides, this technique reduces the problem of overfitting by enhancing the generalization in the model. और फिर क्या होता है, ओवरफिटिंग का भी इशू होता है। ओवरफिटिंग मतलब कैसे? सपोज आपका मॉडल के पास दो किस्म के डेटा है, एक है टेस्ट डेटा, दूसरा है ट्रेन डेटा। अभी क्या हो जाता है कि ट्रेन डेटा के ऊपर ट्रेनिंग हो गई है और टेस्ट डेटा के ऊपर टेस्टिंग हो गई है। क्या हो जाता है, कभी कभी ट्रेनिंग डेटा के लिए जो रिजल्ट्स मिलते हैं वो टेस्टिंग डेटा के लिए नहीं मिल पाते और उस वक्त ओवरफिटिंग के इश्यूज भी होते हैं। Noise is also responsible for the overfitting of the data because the data which you're feeding, the noise looks similar to that data and which causes the issue of overfitting. This is also very underfitting and overfitting are the two issues that has to be reduced in case of generalization in the model. Thus, it helps to better understanding of the data, improves prediction performance, reducing the computational time, as well as space which is required to run the algorithm. So ये सारी चीजों को हल करने का काम करता है। So ये जो टेक्निक है उसे हम फीचर सिलेक्शन टेक्निक बोलते हैं और ये जो टेक्निक है ये ओवरफिटिंग को प्रॉब्लम्स निकालेगी, अंडरस्टैंडिंग के डेटा का बढ़ाएगी, इंप्रूव करेगा प्रेडिक्शन परफॉर्मेंस, रिड्यूस करेगा कंप्यूटेशनल टाइम और स्पेस मिलेगा टू रन दैट algorithm. How many types of techniques are available for the feature selection? So obviously there are 3 types of feature selection techniques in machine learning. One is your filter method, the second one is a wrapper method, and the third one is an embedded method. So we are going to see these methods as far as the feature selection technique is concerned. So let us start with the filter method. So filter method के लिए जो ब्लॉक डायग्राम है वो आपके सामने है। सेट ऑफ ऑल फीचर्स, सो जितने भी फीचर्स आपने एक्सट्रैक्ट किए, कंस्ट्रक्ट किए हैं, है ना, जो भी फीचर्स अभी आपने निकाले हैं, पहले तो आपने टाइप निकाला, फिर कंस्ट्रक्ट किया, फिर आपने उसको फीचर ट्रांसफॉर्म किया। अब आपके पास काफी फीचर्स है जो अभी मशीन के लिए रेडी है, मशीन को देने के लिए रेडी है। सो दीज फीचर्स विल बी गिवन टू सेलेक्टिंग द बेस्ट सबसेट। तो अभी इसमें से कौन सा सेट ऑफ फीचर्स आपको लगेगा जो आपको रिजल्ट देने के लिए काम में आएगा। तो फर्स्ट ब्लॉक इज सेटिंग ऑल द फीचर्स, then selecting the best subset which is given to machine learning algorithm, and then the performance is checked whether the particular subset which you have selected is giving good result or not. This is how the filter method block diagram is. This method uses variable ranking technique in order to select the variables for ordering, and this selection of feature is independent of the classifiers used. So कोई भी classifier use करो उसका कोई संबंध नहीं है, क्योंकि features हम जो select कर रहे हैं वो मेन आपका मशीन लर्निंग एल्गोरिदम से पहले का पार्ट है। तो मशीन लर्निंग एल्गोरिदम में इफ यू आर यूजिंग क्लासिफायर और रिग्रेशन, व्हाटएवर यू आर यूजिंग, दैट इज अ डिफरेंट पार्ट. By ranking, it means how much useful and important each feature is expected to be for classification. अब रैंकिंग मेथड जो लगाई है उन्होंने, रैंकिंग मेथड इसीलिए लगाई है फीचर्स के ऊपर, so that you can come to know how much important each feature is that will be acting for the classification. It basically selects a subset of variables as a pre-processing step independently of the chosen predictor. In filtering, the ranking method can be applied before classification for filtering and less relevant features. So ranking से आपका relevant feature मिलता है और as well as less relevant features मिलता है। तो ये feature selection के लिए बहुत काम में आता है. It carries out the feature selection task as a pre-processing step which contains no induction algorithm. So ये बिल्कुल एक pre-processing step जैसा consider करता है। जैसे feature selection pre-processing करते हैं हम, वैसे ही बिल्कुल वो basically behave करता है. Then what are the filter methods that have been applied? So some of the examples of the filter methods are chi-square method, variance threshold method, and information gain method. Now what is a chi-square test method? In general terms, this method is used to test the independence of two events, यानी कि इनके बीच में क्या रिलेशन है, क्या वो डिपेंडेंट है, क्या वो इंडिपेंडेंट है. If the data set is given for two events, we can observe the count and then expected the count. This test measures how much both the counts are derivative from each other, right? This is done for the chi square test. सीधी सीधी सी बात है, if the data set is given for two events, we can get observed count and the expected count. यानी कि observed count और expected count measure करने का काम chi square test करता है. This test measures how much both the counts and derivate from each other. Then second is a variance threshold. This approach of a feature selection removes all the features whose variance does not meet to some threshold. Obviously हम एक threshold set करेंगे, वो threshold तक अगर आपका feature नहीं पहुंचता है तो उसको वो remove करेगा. That is the removing those features whose variance does not matches with the threshold. Generally it removes all zero variance features, which means all the features that have same value in all the samples. So zero variance वाली features को वो remove कर देगा जिनको तकरीबन सबकी value same आती है. इसे कहते हैं variance threshold value. बराबर है ना? फिल्टरिंग करेगा मतलब उसको कुछ तो देना पड़ेगा फिल्टर आउट करने के लिए, तो वो फिल्टर करेगा, फ्रीक्वेंट फीचर सिलेक्शन को फिल्टर आउट करने वाला है वो. So how he is going to filter out the feature selection? By using these techniques. Third one is an information gain. Information gain or IG measures how much information a feature gives about the class. So how much information a feature gives about the class. Class के बारे में जो information देगा वो information gain measure बताएगा. Thus we can determine which attribute in a given set of training feature is most meaningful for discriminating between classes to be learned. Suppose दो classes है, class 1 and class 2. ये तकरीबन दोनों सेम ही है, लेकिन फिर भी मुझे उनके बीच में कुछ रिलेशन निकालना है, यानी मुझे उनको डिस्क्रिमिनेट करना है कि भाई ये क्लास अलग है, ये क्लास अलग है. तो फिर मीनिंगफुल इंफॉर्मेशन देने का काम करता है इंफॉर्मेशन गेन, बिकॉज इंफॉर्मेशन गेन gives the measures how much information a feature gives about the class. तो बराबर वो दोनों क्लास को आप डिस्क्रिमिनेट कर सकते हो. So इस तरह से तीन किस्म के फिल्टर मेथड्स को इस्तेमाल किया जा सकता है. These are some of the examples of filter methods. It could be more than this, but I do feel so these three are very important. That is chi-square test, variance threshold, and information gain. So this is about the first method. Now second method is a wrapper method. So you can see from the block diagram, the wrapper method can be easily understood. You can see that there are two sets. One is a training set and the other one is a testing set. Training set is given to the feature selection search. फीचर सिलेक्शन सर्च करेगा, उसका उसके बीच में वो फीचर सेट निकालेगा, फिर फीचर इवैल्यूएट करेगा और फिर उसके बाद फीचर सेट को वो इंडक्शन एल्गोरिथम को देगा. Similarly, you can see that the induction program is given to the feature evaluation and then back to the search, there will be a performance estimation कि भाई हमने जो सर्च किया था, वो जो फीचर सेलेक्ट किए थे, क्या वो हमारे काम में आते हैं या नहीं. So now you will be having two outputs from this. One is a training set and the other one is a feature set. So this training set and feature set will be given to the induction algorithm, which will be given to the final evaluation. Now, while doing the final evaluation, you can test the final evaluation with the test set, and then you can estimate the accuracy. This is how the wrapper method works out to be. So it is obviously having two things. One is a training set, test set, then you will get a training set and feature set, then induction program, which will be given to the final evaluation, then the test set and the training set, both will be given to final evaluation, which will help to get an estimation of the accuracy. This is how the wrapper method works. This method utilizes the learning machine of an interest as a black box to score subset of variables according to the predictive power. In the above figure, in supervised machine learning, the induction algorithm is depicted with the trained set of training instances, where each instance is described by the vector of feature values and class labels. The induction algorithm, which is also considered as a black box, is used to induce a classifier which is useful in classifying. So यहाँ पर जो induction algorithm है वहाँ पर क्या use किया गया है? Classifier use किया गया है. सीधी सी बात है. In wrapper approach, the feature subset selection algorithm exists as a wrapper around the induction algorithm. One of the main drawback of this technique is the mass of computation required to obtain the feature subset. So feature subset select karna is the one of the most important tasks in case of this. So this is one of the drawback of wrapper method, that it is difficult to get the mass of the computation required, because what is happening in this is that you're giving the training set to the feature selection approach, then it goes to the feature evaluation, and afterwards it make an hypothesis, and then you make an performance estimation. But it becomes difficult in order to find out whether the feature subset is selected properly or not, because that after selection of the features, it is you're going to come back again to your feature selection search. At that time you can estimate whether your subset of selected features are working or not. So this will take a lot of time, and then you're going to apply to the induction algorithm. So the first part is going to take a little bit of more computation time, and in order to obtain the feature subset. So that is the drawback of the wrapper method. Now, what are the different wrapper methods that have been mentioned below? Are some of the examples, जैसे filter methods था, वैसे ही wrapper methods के भी examples है. One is a genetic algorithm, second one is a recursive feature elimination method, and the third one is in sequential feature selection method. So let us see one by one what they are. Genetic algorithms is the algorithm that can be used to find a subset of features. ठीक है. CHCGA is the modified version of this algorithm, which converges faster and renders a more effective search by maintaining the diversity and evade the stagnation of the population. So genetic algorithm actually subset of features ढूंढता है. अभी इसी का एक modified version भी आया है जिसको हम CHCGA बोलते हैं, that is faster and gives more effective search of maintaining the diversity and evade the stagnation of the population. So जितना भी features है उस features में से subset ढूंढने का काम genetic algorithm करता है, जो कि feature selection का एक important part है. Then comes recursive feature elimination. RFE is the feature selection method which fits a model and removes the weakest feature until the specified number of feature is satisfied. तो वो वीकेस्ट फीचर जो है वो बाहर निकालते जाएगा, जब तक कि वो फीचर्स सेटिस्फाई होता नहीं तब तक वो वीकर फीचर को निकालता जाएगा. Here the features are ranked by the model's coefficient or feature important attributes. So आप कैसे बोलोगे कि कौन सा फीचर वीक है और कौन सा नहीं है? So that can be done with the help of featuring a ranking of the features by the model's coefficient or the feature important attributes. Then the third method which has been applied in the wrapper is the sequential feature selection method. This naive algorithm starts with a null set and then adds one feature to the first step, which depicts the highest order of the objective function. From the second step onwards, the remaining features are added individually. क्या होता है कि सबसे पहले naive algorithm मतलब वो नया algorithm start होता है null set के साथ, उसमें एक features और add होते जाते हैं. जैसे ही हम सारे features remaining features add करते हैं individually to the current subset, then new subset is evaluated. This process is repeated until the required number of features is added. This is called as sequential feature selection. So these are some of the examples of the wrapper method. The third method is an embedded method. This method tries to combine the efficiency of both the previous methods. So दोनों methods जो previously हमने देखे हैं उन्हीं methods की efficiency based काम करता है, combine करता है उनकी efficiency, and performs the selection of variables in the process of training and usually specific to given learning machine. This method basically learns which feature provides the utmost to the accuracy of the model. So ये method जो है वो ऐसे feature select करते जाता है जब तक model most accurate results देता नहीं. Actually, embedded method is nothing but it's a combination of filter method and the wrapper method so that the efficiency can be improved. How the efficiency can be improved is nothing but searching out those features which will give the utmost accuracy of the model. So in this way, you are embedding two methods. That is what is called as an embedded method. Some of the examples of the embedded methods are mentioned below. First one is an L1 regulation technique such as lasso. इसको बोलते हैं least absolute shrinking and selection operation. That is a linear model which estimates sparse coefficient and is useful in some context due to its tendency to prefer solution with fewer parameter values. That is called as the lasso. So you have to see whether your model is linear or not, and it estimates the sparse coefficient that is useful in some context due to its tendency to prefer solutions. That is what the L1 regularization is. इसका मतलब सीधा सीधा क्या है कि lasso क्या करता है, एक लीनियर मॉडल है जो एस्टिमेट करता है कुछ कोएफिशिएंट्स और वो फीचर्स के कॉन्टेक्स्ट में एस्टिमेशन करता है और फ्यू पैरामीटर्स के साथ एस्टिमेट करता है. दैट इज व्हाट द lasso means. It is a least absolute shrinkage and selection operator. Then the second one is a ridge regression, that is also called as L2 regularization. The first one is called as L1 regularization, जिसको हम lasso बोलते हैं, और ये है L2 regularization जिसको हम ridge regression भी बोलते हैं. This L2 regularization is also known as a ridge regression or Tikhonov regression, which solves a regression model where the loss function is linear least square function and regularization. ये लॉस फंक्शन निकालने के लिए काम में आता है. ऑब्वियसली रेग्रेशन है तो रिग्रेशन मॉडल ही यूज करेंगे. उस वो जो आपका मेथड था कौन सा वाला, इंडक्शन एल्गोरिथम, यहाँ पर क्लासिफायर या तो फिर ज्यादा क्लासिफायर या तो फिर रिग्रेशन टेक्निक्स यूज करके ही आप रिग्रेशन मॉडल्स को लॉस्ट फंक्शन निकाल सकते हैं. दैट इज व्हाट द रिज रिग्रेशन इज. एंड द थर्ड वन इज एन इलास्टिक नेट. This linear regression model is trained with L1 and L2. अब ये दोनों L1 L2 देगा as a regularizer, which allows for learning a sparse model where few of the weights are non-zero like lasso, and the other hand maintaining the regularization properties of the ridge. So obviously it is going to use L1 and L2 together, but keeping in mind that the regulation property of the ridge is maintained. This is how the embedded system does have. So here we finish. We'll go once again, we'll revise it, what we have seen. So we are been into the features. So there are 4 types of feature types. So you know ordinal, categorical, and all those features which we have seen in the last type. Then we have seen feature construction. Then we have seen feature transformation. And once you get feature transformation, that is modifying the feature features in order to construct new features from the existing features. Now we move to the feature selection. So why feature selection is very important? Because we need to reduce the data dimension while doing the predictive analysis. And for dimension reduction, feature selection becomes very, very important and concerned, as we know that the data becomes very important as we feed it to the model. So feature selection techniques plays an important role, and best besides this, the technique reduces the problem of overfitting by enhancing the generalization in the model, and it also helps to understand and improves prediction performance. So there are 3 methods which we have seen for the feature selection. One is a filter method. The second one is which one is the second? Third one is an embedded, and second one is the wrapper method. So filter method, wrapper method, and then the last one is your embedded method. So filter method, you have seen that the block diagram set of all features given to selecting the best subset features, and then it is applied to machine learning algorithm and check the performance whether the selected sub features is working properly or not. Then there are 3 examples of filter methods. One is a chi-square test, variance threshold, and information gain. Then wrapper method. So you can see that there is a training set and test set. So for the training set, you have a feature selection search, feature evaluation, induction algorithms. There you keep on selecting the feature subsets by checking, first of all, searching the features, then evaluating, then induction algorithm is applied, then hypothesis is made through induction algorithm, and then the performance is estimated. Then you get a training set and feature set, which is given to the induction algorithm, which may be a classifier or regressor, which is given to the final evaluation, where the test set is tested with the algorithm to estimate the accuracy. This is how the wrapper method works. So some of the examples of wrapper methods are genetic algorithms, recursive feature elimination, sequential feature selection, and embedded method. So it is a combination of the first two method, that is wrapper method and filter method, to improve the efficiency as compared to both the previous methods. So the selection of two methods or combination basically helps you to get the features which will give you the utmost accuracy of the model. So some of the examples of the embedded methods is the L1 regularization techniques such as lasso, then ridge regression, that is L2 regularization, then the elastic net. So this is how the lecture is finished. Have you got any question regarding this, students?
No any questions, sir.
Okay.